Hi there, I welcome you to today's video lesson. We are still on the topic Introduction to Atomic Properties, and this is the second video for that. The link to the first video is the first link in the description. Check it out if you haven't watched that. So let's move on to the main lesson for today. And if you haven't subscribed to the channel, please do well subscribe for me, give a like, and don't forget to tell me your mind in the comment section. All right. So electronegativity, the power of attraction. Electronegativity, the power of attraction. Definition for electronegativity. Electronegativity represents an atom's ability to attract and bond with electrons. The ability of an atom to attract and bond with electron is what is termed as electronegativity. Most cases in covalent bond, the atom with the highest electronegativity value will pull the shared electron pair toward itself. I want you to take note of that. And when that happens, it distorts or it affects the form or the structure of the other atom which is having a least electronegativity value. And when that happens, we say that the structure of that atom has been distorted. Stay tuned. And the chemical bonding, we will tackle that. Don't worry. Periodic trends and variation for electronegativity. Electronegativity generally increases across a period and decreases down a group. I want you to take note of that. Across a period, it increases, and down a group, it decreases. So left to right across a period increases, top to down a group, it decreases. And fluorine is the first halogen, group 7 element. Halogens, that is the first member, is the most electronegative element. Yes, it has the highest value on the Pauling scale. The Pauling scale is a scale reference, or let's say a scale that is used to determine the electronegativity values of element on the periodic table. And the electronegativity value for fluorine, according to the Pauling scale, is 3.98, which is approximately 4.0. Yeah, so that should tell you that. And chlorine is 3.0. You see, also a halogen. Yeah, so fluorine is the most electronegative element on the periodic table. Don't forget, we learned that we have 118 elements on the periodic table, and among them, in terms of electronegativity, fluorine has the highest of them all. The next on my list is electron affinity. Electron affinity. Electron affinity is the energy change that occurs when an atom gains an electron. So you realize that when an atom loses an electron, that energy that will cause the atom to, or that is responsible for the electron to be removed from a given atom, is termed as ionization energy. Now here too, we are talking about the energy that change, the energy change that occurs when an atom gains an electron. So it means that an atom can lose an electron and an atom can also gain an electron. So when it is losing, the energy change is termed as ionization energy. When it is gaining, we term it as electron affinity, electron attraction, affinity. Let's take note of that. Now, trends and variation for electron affinity. Electron affinity increases across a period and decreases down a group. Electron affinity increases across a period and decreases down a group. The noble gases have zero electron affinity. Take note of that. They have zero electron affinity as they possess a stable electron configuration. We've learned that the noble gases or the group 18 element have a fully filled octet, and as a result there is no empty orbital there to accommodate an electron. So they don't have affinity for electrons because there is no space for that electron to occupy. So they don't have any affinity for electron. They have zero electron affinity. Let's take note of that also. Now the next on the list is the strength of the nuclear charge, the Z effect, or the effective nuclear charge. That is the nuclear attraction, the attraction between the nucleus of the atom, which is the center, and the valence shell electrons, or the outermost electron. So the effective nuclear charge refers to the positive charge experienced by valence electrons in an atom. Now, in our previous video lesson, we learned that is the introductory, the first video lesson. We learned that the effective nuclear charge happen as a result of the fact that the protons, which is positively charged, is located within the nucleus of the atom, and electrons, which is positively charged, is also on the shell. And we learned that light charges repel and unlike charges attract. So we have a negatively charged proton within the nucleus of the atom, the center, and we have a negatively charged particle termed as electrons in the orbitals of the various energy levels or shells. So they are unlike charges, so there is this attraction between the two, causing the size of the atom to decrease or to shrink in terms of radius. Yes, so that is the effective nuclear charge. We said the effective nuclear charge, we learned that it is directly proportional to number of protons. So meaning if number of protons increases, effective nuclear charge will also increase. When it decreases, effective nuclear charge will also decrease. And we learned that from left to right across the period, number of protons increases, and thereby increasing the effective nuclear charge, or the Z effect. So effective nuclear charge tends to increase across a period and remains relatively constant down a group. So down a group, it doesn't decrease, neither does it increases, but it remains constant. It affects various atomic properties such as atomic radius and ionization energy. And it's true. We realize that as the effective nuclear charge increases, the atomic radius also what decreases. Next on the list will be ionic size and shielding effect. Don't forget to subscribe to the channel, like and comment. Stay blessed. I love you.